Okay, here we go.
It's okay because we got all of them up. Yeah, you're
Today is all about esters. So whenever we have, can somebody close the back curtains, please? I'm getting some glare up here. I don't know if that's the cause of it or not. Okay, that's not going to work. Let me try one other thing here. That's better. I think it's better. Okay. Whenever you start with an ester, and this is the only time we use this reaction, you are going to break it apart in hydrolysis. Hydrolysis means using water to break something down. Anytime you have an ester, you're going to make two things. You are going to make a carboxylic acid and you're going to make an alcohol. Folks, this is step one. You've got to realize that the only time you do a hydrolysis is when you start with an ester. You're going to make carboxylic acid and an alcohol. Now, things are not that easy because what I'm telling you to do is turn this molecule into these two different things here. A propanal and a 1-chloropropane. So what we have to do is we have to look at these two molecules and we have to end up with these two. Okay. If you know your redox reactions, you know you could reduce this straight to an aldehyde. So carboxylic acid reduces to an aldehyde. Here, you just do a substitution. So you're going to substitute the Cl for the OH. Guys, we could have turned this into this, and we could have turned this into this, but it was easier to do it this way. So once again, we could have oxidized the alcohol to make this. We could have reduced this twice, and then did a substitution to get this. Whenever you get an ester, your first step is always hydrolysis. You're going to end up with a carboxylic acid and an alcohol, and then it will tell you two molecules it wants you to make from there. This is going to be the most involved. Anytime on a test you get two molecules, you're going to do a dehydration synthesis. So if you start with two molecules, you're going to do a dehydration synthesis. But we need to get a carboxylic acid, so we got to oxidize this times 2. So it will be the carboxylic acid plus the alcohol. Listen, 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 listen. Anytime you do a dehydration synthesis, it's got to be an alcohol and a carboxylic acid. What's going to happen is you're going to remove two H's and an O. It doesn't matter which ones. And you are done. Let's back up one step. Let's make sure we understand. If you start with an ester, you go to hydrolysis and break it down and then make what they tell you to make. If you ever start with two molecules, you're going to have to do a dehydration synthesis. Key points: hydrolysis, dehydration synthesis, esters, carboxylic acids, alcohols. For people who are not here today, I will email what you have to get done on the worksheet.